last example where we have something else going on. So now we're considering the same case, but this time instead of ice, we have a block of wood. So now there's definitely some friction going on here, but our table isn't part of the system, which means we're going to be dealing with some friction that is going to be stealing away some of that energy. Okay, so now our block of wood is resting on the table that is compressing the spring, and when let go, the spring expands and pushes the wood across, and the wood is now sliding across the table, except there is friction now. So when we draw the pie charts, this is where it gets a little tricky. So it's going to look pretty much the same to begin with. Gravitational potential energy and some elastic potential energy. Except now, when the wood is going, we're going to be dealing with some frictional thermal energy losses. Okay, so we're going to be losing some thermal energy. So our pie chart is going to look a little weird. We're going to have this like, we're losing some energy. So I drew some question marks there. This is where pie charts have a problem. If we're losing energy, we really can't use pie charts in a, what do you call this? An open system. This is where we have, let's see, let me get an actual reasonable writing utensil here in, how about purple? This is an open system, okay? This is one in which a pie chart doesn't work. And so this is why we're using bar charts now. Okay, so let's see what this is going to look like in a bar chart. Now it's going to look the same as it did before. Gravitational potential energy and elastic potential energy. And when we fill in our system now, see that little arrow right here? This little arrow, let me highlight it. There's our arrow right there. Our arrow is showing that we're losing energy. Notice how I drew the arrow pointing out of the circle because it's leaving the system. Okay, if I were gaining energy, I would show the circle or the arrow pointing into the circle. How would I draw that on a pie chart anyway, right? And so we'll keep going here. So now our final bar chart, it's going to have less energy in it. So think about what that's going to look like in your head. Remember, the thermal energy is lost, and so it's not there. Now you might argue that, well, maybe the wood got a little bit warm too, and so maybe you want to add just a tiny little bit of thermal energy there. And maybe your pie chart would have a tiny little bit, but the table has some too, so it can't have all of it. Okay, so some of the energy was lost. So when some of my stuff is down there invisible. That's okay. So when I'm doing my math down here, like I did before, of my initial energy, I have 2 bars or 2 and 2, and I have 4, and my final energy I have 2 and 1. So that's only 3, which means I definitely lost a bar. Okay, so when I check my math, 4 minus 1 is 3. And so I've accounted for everything. I lost some energy, and that's why I showed it coming out of the system. Okay, so when you're drawing these bar graphs, they're a lot like pie charts. You have to think about what energy is there and some relative amounts. There's wiggle room here because we don't have like some actual amounts that we're working with. We're just considering whether it's gotten bigger or smaller, and that's really what we're looking for. Is it getting bigger? Is it getting smaller? Did you show that in your bar graph? And that's the really important parts. Are you showing the changes? Are you showing it getting smaller or larger appropriately? Are you showing energy leaving? Are you showing energy coming in? That's what your teachers are looking for when they're grading these energy bar charts. Make sure you ask your teacher if you have any questions. There's plenty of practice to work through, and that's all I've got for you. Thanks for watching.